With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. One end of a spring of force constant K is fixed to a vertical wall and other to a body of mass m resting on a smooth horizontal surface. There is another wall at a distance of root 3x0 from the body. Of all the collisions are elastic and spring is compressed by 2x0 and released. Then the time period of small oscillation is. You have been given 4 options. Now for the spring, omega will be equal to under root K by M. Now we can see the spring, when spring is compressed, it goes in leftward direction, then comes back to mean position and then again rightwards, and the collision between the walls is elastic, so therefore no loss of energy takes place. So for leftward motion, let us say T1 will be equal to half of the time period, and we know T is equal to 2 pi by omega. Then T1 will be equal to 2 pi by 2 into under root M by K. Now to get the motion of a rightward direction, we will use the formula for SHM. Y is equal to A sine omega t when it starts from mean position. Here Y is equal to under root 3x0 and amplitude is 2x0 sine omega, and let us say this time is T2 from mean position to the wall. So sine omega T2 will be equal to root 3 by 2, and that comes out to be sine pi by 3. Now we can say, if we compare it, then omega T2 will come out to be pi by 3. Then T2 will come out to be pi by 3 omega. That is pi by 3 into under root M by K. So this time is from mean position to wall and it comes back. Then total time, let us say T3 will be equal to twice of T2. That means 2 pi by 3 under root M upon K. So this time is from mean position to rightward and then rightward direction to mean position. So net time period will be equal to T will be equal to T1 plus T3. That means pi under root M by K plus 2 pi by 3 under root M by K. So this total time period comes out to be 5 pi by 3 under root M by So this will be the answer
for class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.